Thank you so much for being here this afternoon. Today's lecture, Lessons from the Oldest Old, refers to those who are over 90 years of age, the fastest growing segment of the population thanks to advances in public health and medical science. The remarkable individuals in this demographic group have much to teach us, and Dr. Claudia Kawas of the class of 1974 is on the front lines of research about this group. In a few moments, she will share some of what she has learned from those in their 10th decade and beyond. First, though, I want to say a few words about Thomas B. McCabe, a member of the class of 1915, for whom this lecture is named. Among the highlights of his career, McCabe served as chairman and CEO of Scott Paper Company, chairman of the Board of Governors of the Federal Reserve System, and public governor of the New York Stock Exchange. President Harry Truman awarded him the Medal of Merit for his contributions to education, business, and government. During his lifetime, Thomas McCabe received honorary doctoral degrees from 15 colleges and universities, including Swarthmore, where his name, vision, foresight, and generosity endure. Generations of students have studied in the Thomas B. and Jeanette L. McCabe Library. The Scott Amphitheater, where new students celebrate first collection and graduating students receive their diplomas, was a gift from Mr. McCabe. He also established the McCabe Achievement Awards Scholarship Fund in 1952, which has awarded scholarships to more than 300 Swarthmore students over the decades, including this year's McCabe co-presidents, Calvin Chan, Kyle Richmond Crossett, and Lizzie Stant. Unfortunately, Lizzie is unable to join us today, so Calvin and Kyle will have the honor of introducing Dr. Kawas to us in just a moment. Calvin is a junior biology major and statistics minor from Lake Forest, Illinois. Last year, he was co-captain of the men's club badminton team. Calvin is a chemistry mentor, a writing associate, and a research assistant in the Department of Orthopedics at the Children's Hospital of Philadelphia. In his free time, I love this, he enjoys playing ping pong, traveling, and cooking with friends and family. Kyle is a senior honors environmental studies major and honors computer science minor from Springfield, Massachusetts. Kyle has played varsity and club soccer at Swarthmore, and he helps to manage the Good Food Project, a group committed to sustainable and accessible food. This year, he is a President's Sustainability Research Fellow, focusing on renewable energy procurement. In his free time, he enjoys making origami and riding his bike around campus. Please join me in welcoming McCabe co-presidents Calvin Chan and Kyle Richmond Crossett. Thank you.
Good afternoon, and thank you, President Smith. Welcome, everyone, to the 2018 Thomas B. McCabe Lecture. It is our pleasure to introduce this year's speaker, Dr. Claudia Kawas, class of 1974. Dr. Kawas is the professor of neurobiology and behavior and neurology at the University of California, Irvine. She is a geriatric neurologist and researcher in the areas of aging and dementia. Her work is concentrated on the epidemiology of aging and Alzheimer's disease, in the determinants of successful aging, longitudinal and clinical pathological investigations, clinical trials, and, most recently, studies in cognitive and functional abilities of people over the age of 90, the oldest old. After graduating from Swarthmore with a double major in psychology and linguistics, Dr. Kawas completed her medical studies at the University of Louisville and her neurology residence training and a fellowship in dementia and aging at the Albert Einstein College of Medicine in Bronx, New York. After 15 years on the faculty at the Johns Hopkins School of Medicine, Dr. Kawas moved to the University of California, Irvine in 2000, where she is principal investigator of the 90+ study and clinical core director of the university's Alzheimer's Disease Research Center.
Over the past 25 years, Dr. Kawas has published more than 150 peer-reviewed manuscripts and has worked on numerous longitudinal studies, including the Bronx Aging Study, the Baltimore Longitudinal Study of Aging, and the 90+ study, a population-based sample of more than 1,800 people aged 90 and older. Dr. Kawas serves on committees for the National Institutes of Health and the Scientific Advisory Board of several organizations, including the National Alzheimer's Association, the Dana Foundation, and the U.S. Food and Drug Administration. She was awarded the 2017 Baint Windblad Lifetime Achievement Award at the Alzheimer's Association International Conference and the 2017 Potamkin Prize for research in PICS, Alzheimer's, and related diseases. Today, she will share insights from individuals in their 10th decade of life and beyond in her lecture, Lessons from the Oldest Old. Please join us in welcoming Dr. Claudia Kawas.
Oh my, thank you. I can't tell you how a flood of overwhelming emotions comes being back on this campus. It's been 34 years for me, and it's been almost a decade since I last saw Swarthmore. And boy, it's as beautiful as ever, but there's about twice as many new buildings as there used to be. And it's really been a pleasure here, and the biggest pleasure of all has been meeting the students. And in my entire life since I left Swarthmore, I've realized more and more what an extraordinary place this was, exclusively, really, because of the students. And also for the extraordinary people who make it an extraordinary place, including Thomas McCabe. And the McCabe scholars have been especially amazing to me and really given me a lot to go for. So thank you so much. I thank Valerie Smith and all of the people here at Swarthmore for thinking of me with this honor. I'm not sure exactly why in the world I didn't win a Nobel Prize like a previous McCabe speaker, and I'm not the editor of Glamour, and I'm not the assistant secretary for the Health and Human Services or any of those wonderful things, but I'm still very, very honored to be here. So today I'm going to talk about something I wasn't interested in at all when I was in Swarthmore, aging, but I think it's kind of an oxymoron that the older I get, the more interested I am in what I do. Today we're going to learn from the oldest old, a term that has been adopted initially for people who are over the age of 85, but now is mostly used for people over the age of 90. So let's get going. And anyone know who this lady is? I think some of you probably do. Madame Jean-Louis Calment. So Madame Calment was born in Arles, France, and she sold paintbrushes as a child to Vincent van Gogh. And there's lots and lots of wonderful stories about her, but since this is a story about to talk about 90-year-olds, we're going to talk about her when she was 90-year-old. And she had an apartment in Paris, and it was a very desirable apartment. And so she made a deal that's quite common at the time, to get a monthly fee from a 47-year-old man. And she would stay in the apartment, but when she died, the apartment would be his. And it would take about 10 years of monthly payments for the market value of this apartment. You know, you don't have to be a statistician to know the math's pretty good there. He's 47, she's 90, and so in fact he did pay for 10 years, and in fact then he paid for 20 years. And then he paid for 30 years. And then he died, and his widow paid for a few more years because Madame Calment to this day holds the Guinness World Record for longevity. She lived to be 122 and 3 months and some odd days. And everybody always wondered, why would you be interested in somebody who managed somehow to get to 122? But I'm very, very, very struck by this quote a few years ago in Lancet, that more than half of all children born today are going to reach, actually it's going to be their 103rd birthday in the United States. In virtually all of the Western world, children who are being born today should expect to be centenarians and beyond. So it's the fastest growing segment of the population. By far, nothing comes close. And right now in the United States, we only have a couple of million people who are over the age of 90. Some days I feel like I've studied every one of them. But here's what's going to happen over the coming decades, when it's going to more than quadruple in the next 20 years, and we are going to have more than 10 million people in this age group. So what do we know about these individuals? And here is age-specific incidence graph. So what I've got here, as many of you probably can tell, is that at age 70 at this end, you can see the risk of developing dementia in any given year is relatively small, 1 or 2%. By age 80, it's going up to 3 to 5%. And you can see that for every 5 years, there's a basic doubling of your risk, beginning at about age 65. And you can see that the lines, although they tend to scatter a little, they all go up, at least until you get after 90, when something very peculiar happens. First of all, if you believe this graph, then you would tell everyone who lives in Munich, Germany, that they really should move to Rotterdam, or at least Sao Paulo, or, you know, some Minnesota sort of in here. Now, I'm so glad you laughed, because, you know, people look at these things, and if you really believe what you see, then moving would possibly change your risk. But we all, even those of us who don't study this, know that that's probably not true. And the other thing that you see is that while the risk keeps going up until age 90, after age 90, some studies continue to show it going up. Other studies make it look like it levels off, and some actually make it look like it might go down. That is, if you haven't developed dementia by age 90 or 95, that maybe your risk would go down in those studies. So, for example, the men in Utah give the impression that their risk is going down. All of these things can't be true at once, right? And it's certainly, so we don't really know, is the risk of dementia after age 90 down here at 4 or 5%? Is it up here at 30%? And when we started the study, we really had no idea. Although I will tell you, I was wedded to the idea that your risk goes down after age 90. There was a little bit of data that made me pretty much believe that, mostly from Europe, and I actually thought that we were going to see something like this. But we not only don't know your risk of getting it, we don't know the types of dementia you get at that age. We don't know the risk and protective factors. We don't even know the things that encourage people to live to age 100 or beyond. And so there was a lot unknown about 90-year-olds, and that's what made me decide when I first got to California to do a study of the oldest old. And it's been a really, really, really remarkable journey. Mostly when I started doing it, everyone asked me why in the world I was interested in that. And then I think after, you know, public television did a show on us, the first year, in fact, that was amazing. One of our centenarians went on the Jay Leno show and complete with underwater cameras dived off a 3-meter diving board while he yelled, "Go, baby, go." And a few years ago, there was a really nice 60-minute segment, and I actually thought that maybe I'd show you just about a 3 or 4 minute clip from that, because Leslie Stahl is a little better at introducing the study in some ways than I am. So let's just start with that.
We are a nation getting older. By the middle of the century, the number of Americans aged 90 and above is projected to quadruple. Dementia, including that most dreaded form, Alzheimer's disease, is a looming threat and a primary focus of the 90-plus study.
I was born on August 25th, 1920, and I'm 93 plus.
1918.
What they have in common is that decades ago, they all lived in a retirement community called Leisure World, 45 miles south of Los Angeles. Today, it's still a retirement community, and they're still getting the most out of life, though it's no longer called Leisure World. It's now its own city, Laguna Woods. Dr. Claudia Kawas spends a lot of time in Laguna Woods these days. She's a neurologist and professor at nearby UC Irvine who discovered the research equivalent of gold here. Information gathered from thousands of Leisure World residents back in 1981 with page after page of data about their diet, exercise, vitamins, and activities. $6 million of funding from the National Institutes of Health, Kawas and her team set out to find out who had died, when they died, and to convince those who were still living and over 90 to sign up.
Now please spell world.
They are given an hour-long battery of cognitive and memory tests.
Good. Now spell world backwards.
DLROW.
They are checked from top to bottom every 6 months.
Big smile?
Their facial muscles, reflexes, balance,
3, 4, 5.
how they walk, how fast they can stand up and sit down, and most importantly, how their minds are working.
You know, unfortunately, there's no blood test, there's no x-ray. It's an examiner finding out that an individual has problems in 2 or more of the main things the brain does for them.
So what was it that got these people into their 90s
So you've never had a stroke?
No?
while their spouses, friends, and colleagues
Never had hardly anything.
dropped out along the way?
What's your secret?
I wish I knew.
Well, whatever your secrets are, by being in the study, we're going to try to find them out.
Comparing that data to how it's all turned out has yielded a slew of published findings about behaviors associated with living longer.
I really believe that when we learn things from the 90-year-olds, they're going to be helping the 60 and 70-year-olds, not just how to become 90-year-olds, but how to do it with style and as good a function as possible. So, as you saw, I mean, actually, the entire segment, if you want, is to see any more, would be on our website, 90.org. But as you saw, the beginnings of the 90-plus study was the Leisure World Cohort Study, which was actually a mailed survey done in 1981, where a 14-page questionnaire was sent to every single residence of this community in Southern California. And they sent out 18,000 questionnaires, and they got 14,000 of them back. I mean, only in a place like Leisure World could that happen, you know? And I mean, anyone who's an epidemiologist or does survey works knows that, boy, you're really thankful if you can get like 30% or 20% even, and we project who's going to win a presidency with 1%, and sometimes we project it wrong. So 14,000 people filled out this questionnaire. Consistent with the community at the time, they were mostly white. By age 73, which was the mean age at the time, 2 out of every 3 people were women. And I think that that's a notable thing, that in every species on the planet where there's a difference in longevity, it is always the female that lives longer. A relatively well-educated, moderately high SES group, and there were follow-up surveys done 4 times over the next 20 years. So the first thing we did was we said, okay, here are 14,000 people, and we know in 1981 whether or not they were taking vitamins, how much they were exercising, whether or not the women were taking estrogen. So the first thing we did was we said, here's a partial laundry list of the things we wanted to look at. In fact, in the beginning, I was particularly interested in vitamin E and C because, as many of you know, they are considered antioxidants, and there's a whole lot of hand-waving about how oxidative stress has to do with aging, and I guess I was studying aging, so it seemed like an obvious thing. And so what we wanted to do is see if in 1981, for example, you were taking vitamin C, compared to people your same age, who weren't taking vitamin C, did you live longer? So before I get too far in this, out of curiosity, anyone in the room taking vitamin C? How many of you are taking vitamin C? Okay. How about vitamin E? How about vitamin A? Okay. So how many of you think that vitamin C will be related to longevity in this sample? I hypothesized that it would, but so much for that. Anyone want a vitamin A? Well, you're pretty right there. Now, vitamin E was my very favorite. We've done a lot of studies even to try to prevent dementia or treat dementia, and there's been, signals periodically. So how many think vitamin E was related to how long you lived? Yeah, I would have raised my hand for that one too. Calcium, anyone? Soft drinks, good or bad for you? Anyone want tea? Yeah, I really wanted that one too. Alcohol. Oh, well, the good news is this time you're right. Like many studies, we found that individuals who reported modest alcohol consumption in 1981 on average lived longer than individuals who drank no alcohol. Yeah, I like that one too. I tell you, these 90-year-olds have made my career not so much because I'm interested in them, but because they've come up with answers that everybody likes, really. How about caffeine? You are absolutely right. There was a sweet spot for caffeine. Between 200 and 400 milligrams a day was associated with longer life compared to individuals who had more than that or less than that. And everyone always asks, it depends what generation you're from, but that's the equivalent of 2 to 3 cups of coffee, unless you're talking about one of the Starbucks grande lattes, whatever they, do, in which case it might even get you there with just one. Body mass index. How many people thought that being normal weight was associated with best longevity? Okay, how many people thought being underweight was associated with best longevity? And anyone think overweight was associated with best longevity? You guys are the smart ones. Whoops. In fact, and this is, I thought this was fabulous, right about the time we published this, the CDC did a study that was 100 times bigger than our study and found exactly the same thing, which was that normal weight is good, always is good, but in fact, at age 80, or 90, individuals who are considered overweight in their BMI have a 3% reduction in mortality compared to normal weight individuals. And that's exactly what the CDC showed. Individuals who are underweight in our hands and in most every single human study, despite calorie restrictions and all sorts of other scientific evidence, had a 50% increase in mortality. So, let me stop here for a second and make something really clear. Everything I am talking about is about 90-year-olds, okay? And I don't think I've got a single one of them in this room, do I? Okay, so mostly this isn't about you, at least not yet. Not yet, right? And I will even say that individuals in our study who were overweight or obese at age 21, because we also had that information, carried excess mortality for their entire life, even when they lost the weight. So it was never good to be obese, but to be, and then we looked by decade, and it only becomes protective to be overweight when you get to be about 80 and beyond. So one of the mottos in my lab is age matters. Age is related to everything, even though and often we can't tell why, but age matters, and it's not good to be thin as you get older. Exercise. Anyone want to think exercise wasn't good for you? I wanted to think so too, because that's the one thing that really I do need to work on a lot. But in fact, if we hadn't have found this, I would have really been worried about the validity of the entire study. As little as 15 minutes a day in 1981 was associated with mortality benefit over the next 30 years. 30 minutes a day was better. 45 minutes a day was the best, and it wasn't any better at 3 hours a day. So mercifully for a couch potato like me. The other thing is you didn't have to do it for 45 minutes at a stretch. So what we were reporting and studying here, individuals, for example, could take a 20-minute walk and then later in the day do 20 minutes of gardening or whatever it might be, and we added it all together. But being active matters, and the more active you are, at least up until 45 minutes, the longer you lived. Leisure activities. There we put almost everything you can imagine. All the things that people talk about as cognitive stimulation, including crossword puzzles, God bless me. And we also put all social engagement things in there, going to church groups, synagogues, all those things are in there. And those never leveled off. With every additional hour that people reported getting out of the house and doing things in 1981, they lived longer. And we took that out to 8 hours a day. So being active matters. Using your body and your brain very much matters. Now, all of these things matter, though, for the outcome of longevity, just how long you lived. And we had 14,000 people, and we had looked for their death certificates and things, so this study was only about how long you lived. But most of us really care not just about how long we live, but how well we lived during those years. And so we wanted to learn more about these people, and that's really what the genesis of the 90-plus study was. So the Leisure World cohort of 14,000 people, what we said was on January 1st, 2003, and all the time since then, if you were one of those 14,000 people, and still alive, and over the age of 90, we wanted you in our study. And we had about 2,000 individuals that met that criteria. And one of the most remarkable things ever, we recruited 1,600 of them. So we got more than 80% of all of these individuals to agree to be in the study. And I have to say that even though they all lived in Leisure World in 1981, we went to 37 states to see them. And we see them twice a year. So my staff was really sad when the guy in Hawaii died. And they also didn't want the one there's still one in Puerto Rico. They're fighting over who gets to go this winter for that one. And but we go all over to see these individuals. And not only that, we ask them to do an amazing amount of stuff. So when we visit them, we obviously get information about them and their health, and we do neuropsych testing like you saw in the 60-minute video. We do physical performance measures. We want to see their walking abilities. We ask them to give us medical records, let us talk to their families, give us their DNA. We ask them to put their head in 3 different kinds of imaging machines, 2 PET scans and 1 MRI scan at least. And when it's all done, we ask them if they'll give us their brain and let us learn even more from all the valuable information that they've given us. So here's a snapshot of what they all looked like on their first visit. And you can see now that by age 96, there are 3 women alive for every man. About 40% of them were living in some kind of sheltered living, but about a third of them were still living home alone or with minimal or no assistance. And in terms of their cognition, it was about a third had dementia, about a third we deemed normal, and about a third were in an in-between zone where they were suffering from some kind of memory or cognitive loss, but didn't yet meet the criteria that we use for dementia. So now we go back to the slide I showed you before. And what we wanted to know is if you were one of the individuals who came into the study without dementia, and we followed you after age 90, what was your risk of developing dementia? And here is the answer. So, wow is right. It's actually very stunning. It continues, you'll see that our estimate for 90 to 94-year-olds is right smack dab in the middle of everybody else's estimates. Our study is a lot bigger than the others, and so because of that, we were able to do age brackets and have greater confidence in our estimates. And we have a perfect doubling from about 10% per year for a 90 to 94-year-old, 20% per year for a 95 to 99-year-old, and a staggering 40% per year for centenarians. So the risk of dementia is extremely high, unfortunately, and it definitely does not go down, which is not to say that everybody develops it, because that is absolutely not the case. And we had a party this week for some of the participants, and we had one of our 110-year-olds whose cognition was fine. We've had 108-year-olds with wonderful cognition and brains that look like half their age when we look under the microscope. And so now we wanted to go back and say, okay, what about all these things before, and are they related to dementia? I mean, maybe vitamin E doesn't make you live longer, but maybe it makes you live more likely to be dementia-free. So I'm just going to make kind of quick work of this one. None of them were related at all, which kind of is interesting. So then vascular risk factors. I know you see all the time that, you know, hypertension and diabetes all need to be controlled, and they're related to later life cognitive abilities and all that. So we wanted to take a look at that. So the effects of vascular risk factors also held some interesting things. These are odds ratios, and the basic way to read them, if you're not familiar, is that if the dot and the confidence interval, as shown by the lines, is above this 1, then that means your risk of increase is increased. So in this case, you're seeing that if you have congestive heart failure, which 10% of the population did, their risk of having dementia was twice as high as if you didn't have congestive heart failure. And the next one is if you had a stroke, your risk was higher to have dementia than if you didn't have a stroke. And all of these things are relatively true in young people and have been previously identified, so they were more or less what we expected. What we didn't expect was the other end of the graph. At this end, what you see is a third of the participants told us they had a history of high cholesterol, and almost 2/3 of them told us that they had a history of high blood pressure. And because their dots and lines are below the 1, what you see here is that individuals who told us they had high cholesterol or high blood pressure had a 25% reduction in their risk of dementia compared to individuals who never developed hypertension or high cholesterol. And nobody really kind of believed that, and it's interesting, after I started showing this places, several people would come up and say, we found the same thing, but I didn't want to publish it because nothing gets in a scientist's way more than thinking they know the answer. And if we think that these things are at high risk and our data shows otherwise, there's a huge publication bias. But I have to tell you now, there are at least a half a dozen studies worldwide that have shown exactly this result. And the key to it being seen in the study is the age of the participants. So if we study 60, 70, or 80-year-olds, hypertension and high cholesterol is a risk factor, period. Because age matters. If you look at this in 80 and 90-year-olds, then you see something different. And here, in fact, is a good demonstration of that. These are the same participants, but what I'm showing you here is that individuals who told us that they developed hypertension below age 70 or below age 80 here, their risk of dementia is, and were treated for their hypertension and cholesterol. Their risk is identical to individuals that never developed hypertension or high cholesterol. But individuals who developed hypertension in their 80s had about a 40% reduction of risk of dementia, and individuals who developed hypertension in their 90s had a 60% reduction in likelihood of having dementia. So when you're 90, developing high blood pressure and cholesterol appears to be very good, at least for the brain. But what is going on in the brain is the real question. I mean, we, as physicians, we have this horrible habit, basically, of telling everybody they've got Alzheimer's disease because we don't really know what they have, and that kind of seems to fit the mold. And it kind of also doesn't matter because we don't have specific therapies for Alzheimer's disease or any of the other dementias for the most part already. But we wanted to know if hypertension is protecting individuals, or if these are the things we're seeing, what is it protecting them from? So more than 500 people have agreed thus far to give us their brain, and on the results I've got here are the first 300 or so. And the first thing we did was say, okay, if you have dementia when you die in our study, what is the likelihood of finding Alzheimer's disease? And it turns out it's about 60%, which is pretty much what most people in my field would have predicted. About 60% of dementia, 2/3 of it, appeared to be due to Alzheimer's disease when you looked at autopsy. Now we want to know, if you don't have dementia, what does your brain look like? And it turns out that there's a 40% chance that it looks like you should have dementia. 40% of non-demented individuals who come to autopsy in our study have significantly high levels of Alzheimer's disease pathology, such that they would be normally assumed to have serious problems with their thinking and cognition, and yet they don't. And here's an example of one of those. So on the left is a normal person. In this top panel, we show what we call senile amyloid plaques. And this one we show neurofibrillary tangles. Those are the two key proteins that we associate with Alzheimer's disease. And you can see there's no senile plaques in this person, and there's only a few tangles. And that's in contrast to this individual who had dementia and had a lot of senile plaques and a lot of neurofibrillary tangles. But in the middle panel, you'll see an individual who did not have dementia, who has just as much senile plaques and neurofibrillary tangles, and yet managed to maintain good cognition. Now, there's a real big debate right now in the literature, and the first thing people said to me when they saw this was, oh, that person in the middle just didn't live long enough. I said, well, 96, I mean, I'm sorry I couldn't make them live any longer. But their attitude was, oh, they just died before they expressed it, and if they'd lived another year or two, then they would have been completely demented, and I just happened to, hit this perfect moment where they've got the disease in their head, but it hasn't quite yet caused all the mischief that we're certain it must cause. But increasingly, we are starting to think that maybe it might be that these individuals actually have some resilient factor that allows them to have this pathology in their head and nonetheless maintain a healthy brain and good cognition. And there's two camps on that, but I think like most things, it's probably going to turn out to be both. I think some people, it is going to be the early stages of dementia, and we hadn't seen it yet. But I think in many people, I'm increasingly believing that it has to do with some sort of ability to be resilient to the disease. Now, up until now, the only way we saw this kind of thing was by having an autopsy. Very few people do autopsies in the hospitals anymore. Even research studies aren't nearly as interested in autopsies. I'm the daughter of a pathologist. I had no choice but to be interested in autopsies. But I honestly can say that it's really where we've learned our most amazing things. And although I'm going to show you something about imaging briefly in a second, it is never going to replace what we can see under the microscope. It really, really is not going to. But a few years ago, the FDA approved a ligand for PET scans designed to show us the top panel of amyloid plaques that I showed you. And this is what one of those looks like. Well, actually, this is what two of those looks like. So these are two of our participants. This individual is positive for amyloid, basically shows on the pictures as the hot orange areas. This individual is amyloid negative. This is just an ear, that doesn't count, look above here. But you can see here in their brain, they essentially have no amyloid, whereas this individual is amyloid positive, and they not only have a lot of amyloid, they have it in exactly the places that we associate with Alzheimer's disease and know it collects in Alzheimer's disease. I showed this picture at the appreciation party last week, and as one of the participants was walking out, he said to me, "That's my brain you showed." And he is right. And he actually is the positive one, and he knows he's positive. He has been positive for at least 8 years. We've scanned him twice. They were both positive. I don't even know why I bothered the second time. And in between the two scans, he also had a stroke, by the way. And despite all of that, his cognition remains normal. So it's people like him that make me think that there might be something to this resilience thing. And it's going to be very, very, very interesting to understand better what's in his brain and his DNA. Now, everybody thinks there's a scan right now under development for the bottom panel, the tau and neurofibrillary tangles. That's actually was just recently or about to go to the FDA for probable approval soon. But I can tell you, as somebody who's been doing these for a long time, I mean, in the last month alone, we had 2 individuals who were either positive or negative in their scan, which within the last couple of years, but on autopsy was the opposite of what their scan said. So everybody thinks they're really seeing everything exactly as it is with these scans, and these are really just approximations, but a pretty good approximation. And I think now, knowing how, when I saw somebody at autopsy with plaques and tangles, I didn't know if those had been in their brain for a day, a week, a year, 10 years. And now with this tool, I think we're going to be learning a lot more about how long people can tolerate it. What we do know, though, is even in normal Alzheimer's disease or familial Alzheimer's disease, we believe that people have plaques and tangles in their head at least a decade and as much as 2 decades before they express memory loss. So it can hang around in your head for a long time before we see the trouble that we associate with it, I think. And that's something hopefully we'll figure out how to learn from keeping it to progress. But we don't have any imaging or any other way of seeing most any other dementia-causing pathology in the brain. So here is a picture of what Alzheimer's disease looks like under the microscope. But how many of you have ever heard of hippocampal sclerosis? Well, I'm going to do my best over the next few years to change that, because it accounts for 1/3 of all dementia, at least in people over the age of 90. We don't know how to diagnose it. We don't know what the risk factors are. There's no imaging that'll identify it. The only way it can be diagnosed is at autopsy. It overlaps frequently, so I think a lot of the people we call Alzheimer's disease, though, really don't have Alzheimer's disease at all. In this slide, microinfarcts, these are microscopic infarcts, once again, cannot be seen on imaging because they're too small. They can only be seen under the microscope. And it turns out if I look under the microscope at 6 slides and I find 3 microinfarcts in your head, that your odds of dementia are as high as if you had severe Alzheimer's pathology in your head. And white matter disease is another one. So what about all these other things? Well, I thought this was particularly interesting when you look at it this way. So if you have Alzheimer's disease alone in your brain when you die, you have 3.5 times increased likelihood of having dementia than if you didn't have Alzheimer's disease. But if I add any of those other things, your risk of dementia goes up to 12-fold. And if you only have one of those other things, though, your risk is always high. So here, I jumped here. Your risk goes from 3 to 13 if I go from Alzheimer's alone to Alzheimer's plus. But if you had hippocampal sclerosis, your risk is 12 instead of 2. So I've always surprised people when I say, if I had a choice and if I had to have something in my head, there is no question, hands down, give me Alzheimer's disease. I mean, everybody acts like it's the most dreaded of all the things that happens in your brain, but in fact, your risk of having dementia is much worse with all the other things that I showed you, most of which you've never even heard about or don't hear research about, although it is ongoing more and more. And the more of these things you have in your head not only affects your likelihood of dementia, but the severity of dementia. So this is the mini-mental, and if you had no pathology in your head, we still had significant numbers of people who looked demented with that, but your dementia was mild. If you had one, usually Alzheimer's disease, your dementia is now in the more moderate to severe range, but if you had 3 or 4, you're at this range on the mini-mental, which means basically only able to answer very simple questions like your own name and where you are maybe, although probably not the date or even the year or any of those other things. So with this in mind, we wanted to know what would be the effect of, if I found the magic bullet for Alzheimer's disease, which everybody is looking for and we're spending a lot of money on it, and I succeeded in wiping every plaque and every tangle off the face of 90-year-old brains, how much dementia would be still left, would be treated successfully with that approach. And so we did that calculation, and you can see in growing amounts of pink, complete elimination was the hottest color And then we looked at more modest and more likely scenarios for the drugs that we're currently developing to see how it would change the number of cases. And here's what happens. So right now in the United States, we have about 1.25 million individuals over age 90 who have dementia. And if we were able to completely eliminate it, you'd see that we would get rid of about half of the dementia down to here. But what's really striking is what it's going to do over the next 20 and 30 years. Because by 2050, we are going to have more cases of dementia among 90-year-olds than we currently have in the United States at all ages put together, including 90-year-olds. And that's going to be almost 5 million people in that age group alone. And reducing that to a little over 2 million will really have an unbelievable public health impact. But still leave, obviously, a lot of cases and a lot of things for us to worry about as we get old. So, just to summarize, we're all getting older. We've extended life by 28 years in this century, and I used to say that'll never happen again, but I have to tell you, we are continuing to extend life, even though you read things in the paper saying that the last couple of years that's not been the case. The numbers are actually completely driven really by suicide and opioids. And if you take them out of the mix, people are still living longer than their parents did and extending life by a month or so every year, actually. The risk of dementia, unfortunately, though, is high at this age, and it's probably due not to one, but to a lot of different pathologies. So we're really going to need to step up our game as scientists and figure out how to deal with things besides Alzheimer's disease, which, in all fairness, we've not been nearly as successful as I had hoped we would be by now. Many people have good cognitive abilities, to 100 and 105 and 110. A Nobel laureate came to our party last week, and he walks in and he says, I'm really sorry my wife didn't come, but we just flew back last night from Edinburgh where I gave a lecture, and she was jet-lagged. It's like, I got jet lag coming to Philadelphia, and I wouldn't have gone to that party for that horrible quiche the next day. But, at 95, he's running circles around me, and many of them do. We really don't know enough about the risk and protective factors related to all these different types of dementia, but there's no question. In old age, there is wisdom, and elderly people have a lot to teach us, at least if we want to become one of them. So this is from my local newspaper a number of years ago, and I think it's actually true. 95 is the new 65. So once again, I want to thank President Smith and Swarthmore and Brian and everyone who's made my stay here so lovely, and especially to the students and for you guys for coming for a lecture in the middle of a Saturday. Okay. Thank you.